Yeah, the last part here is the key metrics in performance testing. Yeah, so we do use multiple tools to do all this testing, but at the end of the day, we need to understand what are the key metrics that we need, right? So that's the main thing. So the first metrics, as we all know, the very common one, that is the response time. So when it comes to response time, we do collect multiple response times. We do collect the minimum, average, maximum response times. We do collect the percentile as well, right? The 90th percentile, the 95th percentile. So all these comes under the response time. So when it comes to response time, so what does it mean by response time? So people used to confuse a lot. I even in fact created a separate video on what there was a question. Actually, one of our subscriber had asked me a question like, what is the difference between latency and response time? Because he think that okay, both latency and response times are same, but there is a difference between the latency and the response times, because latency is something like the time it takes. Okay, let me draw a quick picture. So when it comes to response time, it is again a mix of latency, because your browser is here. So you have your machine, your browser, and you have the app service, all the machines at the business end. So what happens is, when it comes to latency, it is the time that it takes from the business to, or from the browser to reach to the server. That is the latency. That is the latency. There is not much anything else. It all depends on the throughput. It all depends on the bandwidth. So everything is part of your latency. And after that, the request again comes back from the user to the browser. So there are like two latency that has been involved. So the time it takes from the browser to the server, and the time it takes from the server to reach the browser, that is the latency. But what is the response time is, it is a mix of latency plus processing. So that is the, oh, sorry, that's the mix of latency plus the processing is the response times, right? So you do send a request, come on, you do send a request and it gets processed at the user's end, it gets processed at the server, right? So all these added becomes the response times. So it takes time to reach the server, it gets processed there, and then the server sends back the response to the. So it is, so browser, I mean, like a response time is a addition of the time it takes for the request and for the processing and the response times back to the server. So combined, all these is the response time. But when it comes to latency, it's just the time taken for the your request to reach the server. And yeah, so we do collect the minimum response times, which is the very minimal time it takes for the request to get processed. That's the minimum response time. And then we do have the average response time, which is the mean time for all the requests. And then we do have the maximum response time, which is the maximum amount of response time, the peak response time. That's or the longest time, I would say, for the request during the test. And then we do have the percentile. So when I say percentile, we do have we can collect, I mean, the 90th percentile, we can collect the 95th percentile, and then we can collect 99%. So all these three are the common percentiles that we do collect. So we'll see how to collect these percentiles if you haven't watched it in our another video. So that these are the response times that we collect, and the importance of response times. So why do we need to collect response times? What is the objective of collecting it? So the objective of collecting the response time is to indicate the speed and the usability of the system. So how quick or how speed our application is. So that is the main objective of collecting the response times. And say for example, like you have a API, a login API. So when you're collecting the response times, we are finding that uh, say for example, you have an SLA, like my application should the login should work under 3 seconds. Yes, so you're collecting a response times to see how quicker your login API is working. So your login API should respond within 3 seconds. So that is your response times, and you do have an SLA for that. So that is the response times. So this is the main metric, I would say, the majority of the metric that we do collect. So any doubts on this in terms of response times you do have? Any queries? Are you okay with understanding the response time? Guys, any doubts? Are you good?
No, Vasant, fine.
Okay, thank you. Thank you. Thanks for confirming. Fine. I will move on to the next one, and that is okay. Let me just quickly erase this part. The second one is the throughput. Let me add it here. Okay, so when it comes to throughput, okay, right. When it comes to throughput, what is a throughput? So throughput is the number of requests or transactions the system processes in a second or in a minute. In a second or a minute is the throughput. So how many requests or transactions that the system processes. It's not just about sending your request. It's just about how much time your server, right? You have a server, you have a system, and that has to process the number of requests. And why is it important here is you are sending 1000 requests, right? But your system can handle only 100 requests at a time, in a particular second, in a particular minute. What happens here is all the other remaining 900 requests will have to wait. They'll have to wait in a queue. And if there are additional 1000 requests that is coming in, they also have to wait because there are already 900 requests that are waiting in the queue because they're not getting processed and they are waiting for the first previous 100 requests to get processed, right? So the throughput is very important because this will actually tells you how effective or how capable your server is, right? Because the amount of throughput should be high automatically because your any number of requests you can send. Like if you're sending 1000 requests, yes, that should get processed. And you if you're sending like 10,000 requests, yes, that also should get processed because the users are waiting outside. They are keep on sending the requests, and you do not take too much of time for processing your requests. And that's why we are supposed to see the throughput. And it is again, I'll again reiterate. So the number of requests or transactions the system processes, it's not sending or it's not receiving, it's processing. So the amount of requests that you're processing per minute or per second is the throughput. And it is measured in we measure the throughput. Oh, come on. We measure the throughput in requests per second or transactions per second. So that is about the transactions. Is this here? Okay. And we measure it in TPS. So we'll see transactions per second or requests per second. That is the RPS. So the importance of or identifying or calculating the throughput is it reflects the system capacity. Yes. So this tells you what is the capacity of your system. So if the throughput is less, which means the capacity is less. If the throughput is more, like if the throughput is high, yes, then the capacity is high because you are able to, or your system is able to process more and more requests, and it also shows how efficient it is. So that is about the throughput. That's about how much throughput the server can handle. And just to give you a quick example, so you have an e-commerce website, and if it can handle 2000 purchase transactions per minute, which means it is highly efficient because you are able to process 2000 transactions per minute, right? So that's highly efficient. That's highly processable. That's more of a high process environment, more high process server, right? So that's about the throughput. So you should see throughput to make sure. Again, response times and throughput are interrelated because the more quicker your system processes your request, then you get more a lesser response times, right? So every metric that you're going to discuss today is going to be interrelated. So the more quicker your system processes, the more quicker you have your response times, right? That's about the throughput. Any doubts in terms of throughput?
No, Vasant.
Okay.
It's good.
What
Thank you,
will be the
Rajesh.
ideal? So when you say more, when you say the throughput should be more, so
Mhm.
what will be the ideal or what? So what will be the SLA? How to determine whether the throughput is good or bad? Any benchmark?
Okay, so you can find that using the number of requests. Say for example, you will have, I mean, like your requirements will come from the user that, okay, I have 100 users who are making their transactions. So that, so we normally get the SLAs from the current requirement, from the current application. So that's about the existing application. But when it comes to new application, yes, the user will have their own set of requirements. Say for example, if they think that, okay, I have like 10,000 users who are registered users, so they are the one who are going to use this part, who are going to hit this API. So in that case, you will have 10,000 requests, right? Because you do have 10,000 users, so automatically there will be 10,000 requests. So that's good. So you do have 10,000 as your TPS transactions. Maybe you can break that, like for example, like 1,000 requests, because you don't find all the users will be hitting at the same time. So you do break down your total user load. Like if you have like 10,000 users, then you can actually break it down. Like I have actively 500 users who are using my application. So all these can be taken from your analytics part, and you find that, okay, I have 500 transactions, I have 500 requests per second, and what could be the response time for that? That's what I'm saying. Throughput and response times are related, both are interrelated. And your expectation or your SLA is, I have these many users who are registered, and this is going to be my TPS, or this is going to be my RPS. So I have to handle that many users at a moment, at a time.
So my question is, when can you say that the throughput is good? Let's say my
Ah,
throughput is like
okay,
200.
when your response times are lesser, you can
Okay.
say that your throughput is good, because your response times will be lesser only when you have high throughput.
You
When
cannot
you
read
have a
from
lesser
the
throughut, yeah,
TPS.
yeah, go ahead.
No, you cannot read from the TPS. You are dependent on your response time.
Yeah, yeah, that's more the interlayer, and you can see the throughput numbers as well, right? You can see the throughput numbers. You can see how many transactions per second is happening. So you can see that as well. But
Okay.
to confirm that your transactions per second is good, you can confirm that only through your response times. So that's a confirmation point. You can access any number of requests at in a second, but all you confirm that, okay, I can handle 1,000 requests, I can process 1,000 requests per second. But how can you confirm that? All you can confirm that using your response times.
Okay.
Yeah, because the quicker your response times means your processing power is higher, your processing time is lesser.
Yeah.
Yeah. And yeah, thank you, and we'll move on to the next one, that is the concurrent users. So let me quickly. So the next thing is the concurrent users. So what about concurrent users? So the number of users, I would say the active users. So the active users who are interacting with the system simultaneously is the concurrent user. So I would say the number of users who actively interact with the system simultaneously. So these are the concurrent users. Again, why do we need to bother about them is they are the user load, right? So they will help us to determine how the system behaves under real world usage conditions. So who are going to give the throughput? It's coming from the users, right? So that's how the concurrent users, like I told you again, all these are interrelated. So the response times are related with throughput, the throughput is related with the users. So now you're going to determine how many users who are actively interacting with the system, and we'll see how the system behaves under real world usage conditions. Say, for example, we have like 1,000 users who are accessing a website without the performance that is getting degraded. So that is the idea about the concurrent users. So you know how many. So when you say, I have 1,000 concurrent users, so which means you will be obviously getting almost around 750 to 800 TPS, and that will in turn towards your response time. So all these are related, and now the third one is the concurrent users. And the next part, yeah, this is the one that we have already discussed, and that is the uh, latency. So what is latency? So latency is, again, I have told you, it's a time taken to reach the server. So you have your browser here and you have your server. So the time taken for a request. So you're sending a request, and the time it takes for the request to reach to the server for the first byte of the response to be received. So we normally do it as like the TTFB. Again, this is another front end metric that we collect. We do have the time to first byte. If I can open my Lighthouse, I can show it to you. So actually this indicates the network and the server efficiency, because you do use a network, right? And you do also use the server. So it's a mix of network and the server. You can actually calculate the network and server efficiency. You don't calculate it as a separate metric, but this comes as part of your response time. So latency should remain under 100 milliseconds for a smooth user experience. And it also depends on the, like I told you, it depends on the network, it depends on the bandwidth. So all these are part of the latency. Like even though you do have a higher bandwidth, but it also depends on the network as well. Like if there is like a lot of traffic that's been moving on, if you don't have proper uh, bandwidth, like you don't have proper latency, then yeah, there will be a little bit delay in terms of your request to get reached to the server. So that is the latency, the time. So the time taken for your request to reach the server and for the first byte. So that is the latency. And moving on to the next one, which is the error rate. So why error rate? I've told you in the very beginning, we don't test the failure scenarios, but where does this error rate comes in? So the error rate is something, the percentage of requests that fail due to errors like server timeout. So we do check, we do see the 500 response code, we do see 400, we do see 404. So all these are part of your error rates. So we do check all these error rates. We do check for validation failures. So let me give you the formula for this real quick. So how to calculate the error rate in percentage. So when you're using your Neoload, you can see this error rate percentage. So that's like the failed requests divided by total request multiplied by 100. So you can see, say for example, you have like if you have like 10 requests that has been failed for your total 100 requests, which means like you have like 10% failures, you have like 10% of errors. So this actually tells you, or this actually shows you the reliability and the robustness. Say for example, if you are running your test and your server does not respond, or if your server fails, so that means that your application is 90% capability and it's not 100% capability, because you do observe 10% of errors, right? And it's if it is, it should not be like a test data issue, or it should not be like any other test related data. It should be server related. It is not like you have given some wrong test data as part of your testing, and if it fails, no, that's not part of that, should not be taken as your error rate. All you have to take is the 500 internal servers. Any errors that comes as part of the 5xx or the 4xx. So all these things has to be taken as part of your error rate. It's not just about the other issues. It has to be, the thing is, like, we are going to identify the previous metrics, like the capacity of your system, the throughput, the amount of requests that is getting processed. So all these, like I told you, they're interrelated. So the error rate is again to tell you that what is the capacity. Like if your system is not capable to handle more requests, yes, you do automatically see that the connection has been closed, the server is not responding back. So all these things you can expect only when your system or error goes bad. So yeah, that's about the error rates. And then moving to the peak load. So peak load is another metric that we collect as part of your testing. So in peak load, we used to collect the maximum number of users or the transactions that can be handled without any performance degradation. Again, this is another metrics. As you all know, it will be collected as part of the stress testing. Yes, like I told you, we can collect the maximum number of users or maximum number of transactions, the TPS, that the system can handle without any performance issues. And this will actually determine what are we going to determine. So as part of the stress testing, so we are going to determine the upper performance limit of the system. So that's what we're going to calculate as part of the peak load. So again, this is part of the, not the load test, but this is part of your stress testing metric, right? And the importance, okay, the example is that if the application can handle like 10,000 users or like 1 million users, that is going to be your peak load. And that's going to be the peak load metrics stress testing, for stress testing. And then we'll move on to the next one, that is the CPU and memory utilization. All these you're going to see it in the VM part. So what is the CPU and memory utilization? So the percentage of CPU and memory resources that is used during the test, that has been utilized during the test, is not in a normal time, not in a ideal time, but in a time where you are running your test. That is the CPU and memory utilization. Again, the reason I'm mentioning is you could have this question in your interview. They might ask you like, what is the CPU and memory utilization? So the CPU and memory utilization is something you're going to analyze, or you're going to find during the test, not during the other time. So that is the CPU and memory utilization. So the importance of this is to identify any resource bottlenecks. So to identify any bottlenecks, yes, we do have to run the CPU and memory utilization. So the threshold. So what is the acceptable threshold? So utilization should generally stay below 70 to 80% for a better scalability, or a better stability. And if your CPU usage spikes to 90% under load, which means there is an issue with the with the application, like it should not go beyond that. And if it is beyond that, then it could be a scalability issue. It could be a issue. Maybe you can have like more amount of users, more than the system could handle. So that is another pointer that tells you that, okay, you have to now scale out your application, or you have to like scale up your servers, right? So that's about the CPU and memory utilization. So any doubts so far? And when it comes to memory, yes, we do check the memory leaks, and that's again a very big topic where we'll have to deal with that a separate in a separate day, because you do have come across a point called garbage collection, where if a new object is getting where an object is getting created, and if it is not been removed from the system, and when new objects are getting created, it does not have enough space. So what happens, like there will be a memory leak that's happening. So all these things has to be, I mean, like this again, CPU and memory utilization will be part of your any of your load testing or stress testing or endurance testing. In endurance testing, you would see the memory leaks. So that's the main metric that we used to see when you're running endurance testing and 8 hours or 12 hours testing. So yeah, again, these they differ in terms of how we see, but again, we see the CPU and memory utilization on all the tests, in all the load, stress, and scalability, and even endurance as well. So any doubts before we move on to the next one? Yeah, Rajesh, you have anything to say?
No, we are good.
Okay, thank you. And we'll move to the next one, that is the disk input output. So this one, this metric, the disk input output, tells you the rate at which the data is read from or returned to the disk, because that's another important one, because you do have a disk that has all the data, and you must also see how quickly it gets read, or you are going to write the data to the disk. And when it say read, you're going to read from your app server, you're going to read from the database server, and you're going to write as well, right? You're going to when it comes to read, you're going to read your login data, login username, password. When it comes to write, you're going to add items, you're going to add the payment details, all your card details, everything is going to be written to the disk. So that is the disk input output, and it is very critical for database intensive applications. It's not about the you're not going to worry about disk input output for non-database. When I say non-database, are where you have database more, not you're not going to use it extensively, but you're going to use it in a lesser lesser fashion. But when it comes to disk input output, like I told you, you're going to read your login details. Sorry. You're going to read your login details, and you're going to write your payment details, your credit card details, and everything is going to be written. So, and you're going to do it again and again and again. So in that case, it's more intensive. It's more going to be database intensive application part. So in that case, yes, disk input output is very important. And when it comes to high disk input output during a report generation process, it can slow down the application because you're going to read a lot of item from the system. So that's about the disk input output. So like I told you, so you can ask me like, okay, do I need to check disk input output for all the applications? No, it's not just like that. It's about the more about the database related applications. And the next one is the network bandwidth. So the amount of data that has been transmitted over the network per second is the network bandwidth, and it is measured in MB, megabits per second, or in terms of GBps. And the importance of calculating this network bandwidth is to ensure that the application works well in varying network conditions. Say, for example, if you are using a mobile related application, say, for example, if people who are using 4G, 5G, and Wi-Fi, so you have to test your application in different, you're going to emulate your testing in different network. Right, so you have to test the same application with 4G, you have to test the same application with 5G, and also you have to check with the Wi-Fi network as well to check how well your application works with a different network bandwidth, because that's again another scenario, right? People used to use, like, say, for example, if you are someone who is using uh, an app like Ola or any other riding app, like, and you are in the remote location, and when you want to book something, you should not wait for a long time, right? Obviously, you should react very quickly. Your application should load very quickly. Only then you can book anything. Like, just for an emergency, you are booking something, searching for something for emergency, and you have to check all these. You should not have an idea that, okay, every user will be in 5G network, and every user will be doing their booking from home, right? So understanding all these scenarios, yes, we do have to check, we do have emulator test with different bandwidth, right? So, and also you should check it will handle high operation, high amount of load, and even from the minimum load to the maximum load. And that's about the network bandwidth. And then we do have the scalability. So when it comes to scalability, it is the system's ability to handle increased load by adding resources. So we'll determine that whether the system can grow with user demand, and also we'll add more server more server increases user capacity from 10,000 to 20,000. Say, for example, like when we are scaling up the users, automatically we have to increase the amount of servers as well, right? So that's comes the scalability. And finally, the availability, like I told you, the 99.959 percentage. So you have to also check the availability of your application, like when you're running your stress testing. So you have to check how long or how well your application is available during the entire load test. So all these are the metrics for the performance testing. So next week we'll start with JMeter. And any doubts so far, guys, in terms of whatever we have discussed today?
They're good, Vasant. Actually, do we provide any notes, like any for these
Yeah,
sessions?
this video will be shared in the YouTube channel, so you can
Yeah.
refer it from there. Yeah.
If you have any PDF, like thing, we can refer it easily.
Mhm.
Both actually, I think
Yeah,
videos are
sure.
good.
If there is anything, yeah, I'll definitely share it with you. Share it all. Yeah.
Sure.
Mhm.
Thank you.
Sure.
And
Yeah.
Vasant, I have one question.
Yeah, please.
Like before starting performance testing assignment, we will need to discuss on the SLA with the client.
Yes.
So I was thinking like if we can discuss on that topic as well, like what all details and points we should discuss with the client before starting the performance testing work.
Yeah, that will be part of your test planning. So that we'll see next week.
Mhm.
How well do you collect your test planning? Like, again, there are like two ideal scenarios. One is if your application owner does have knowledge on performance testing, what will be your approach, and what if it does not have? And if your application is an existing application, how will be your approach? And if your application does not have, like, what will be approach? So we'll discuss that in the next. I mean, that there are like lots of ifs and buts and lot of branches. So we'll see that in the next session. So mainly it comes under test strategy and test planning. We'll see that. We'll start from that next week.
Sure, no problem. Thank
Mhm.
you.
Yeah, thank you. And any other doubts, any other queries? Okay, thank you so much. I think I have taken too much of time from you today. Yeah, so next week we'll see with the test planning. So that's more important even before you work control. Thanks, Ajis. So we will see about how to create your test plan, or how to do the workload modeling and everything. So that's going to be more interesting, and that will be very helpful for you, because that's something what you do for functional testing. So we do have a test plan for functional testing. So same thing we do have for non-functional testing as well. Yeah, Sunil, you want to see something? Okay, I think you went on mute. Back in. Thank you. Yeah, so like for functional testing test plan, yes, we do have for performance testing as well. So we do see that in our next session. Thank you so much for joining, and thanks for your support. And before we move on, we'll start with some questions next week, and then we'll start. Thanks again for joining. Thanks for all your time, and we'll catch up next week. Thank you so much. Thanks everyone. Yeah, thanks,
Thank
Deepak.
you.
Thank you. Thank you.
Thank you, Vasan. Thank you.
Thank you.
Thank you. Yeah. See you all next week. Bye bye.